tutorial is going to cover types, variables, and expressions. Before we start, make sure you have Java downloaded on your computer. You can check that by running java-version in your terminal, and make sure that you have IntelliJ downloaded on your computer. If you haven't already, it's suggested that you watch IntelliJ and the first Java program tutorial that's in this same playlist. So we're going to start with types and variables. Here's some vocab. A type is a category or set of data values. It affects the types of operations that can be performed on data, and in Java, you'll always need to specify the type of the data. Statically typed means the type of variables is checked at compile time, and Java is statically typed. So the type is checked when the code goes from being written in the programming language to being converted into the language that's actually going to run on the computer. And then dynamically typed is when the types of the variables is checked when the program actually runs or at runtime. And for example, Python is dynamically typed. And then primitive types are the 8 simple types for numbers, text, etc. So why do languages need types? Computers see information as a stream of ones and zeros, and types tell the computer how to view those ones and zeros. And each type has distinct property values, value ranges, and number of ones and zeros it takes up. And some more vocab. Binary are numbers written in base 2, and they become basically a collection of ones and zeros. For reference, normal numbers that we use in the US are written in base 10. And a bit is a single 1 or 0 in a binary number or in the computer's memory. A byte is a collection of 8 bits. A nibble is a collection of 4 bits. And a hexadecimal number is a number in base 16. And for that, the values get switched to letters after 9. So once you get to 10, it becomes A, 11 is B, etc. And one nibble in binary is one number in hex. The 8 primitive types are byte, which is an 8-bit signed whole number that goes from -128 to +127. A short is a 16-bit signed whole number that goes from -32,768 to +32,767. An int is a 32-bit signed whole number that goes from -2 to the 31st to +2 to the 31st minus 1. A long is a 64-bit whole number, signed whole number, and it goes from -2 to the 63rd to 2 to the 63rd minus 1. And you can see a pattern there, right? However long the number is, that's how you know what the range is. So it's 2 to the n minus 1, where n is how many bits the type is, to positive n minus 1 minus 1. And then a float is a 32-bit non-whole number or floating point, and that's used when you're wanting to save memory for a non-whole number. And then a double is a 64-bit floating point number, and it's the default choice for non-whole numbers. A Boolean is a truth value, so it can be either true or false. And then a char, which is short for character, is a 16-bit Unicode. For example, A. And you can also set the values by their ASCII value, and that's a number that corresponds with whatever the Unicode character is. So some more vocab. A variable is a piece of the computer's memory that is given a name and type and can store a value. Variable declaration is what sets aside memory for storing a value. So an example would be int x. So now the appropriate number of bits have been set aside in the computer's memory to hold whatever x ends up being equal to. A memory address is where in the computer's memory a variable lives, chosen for a variable during declaration. When it's printed, it's often shows as a hexadecimal number. Assignment means to store a value for a variable. So an example would be int x equals 3, or just x equals 3 if x exists already. And this semicolon is important because, as mentioned in the last tutorial, all statements in Java have to end in a semicolon. And then a cast means to force one variable to be a different type. And we'll see examples of that later in this tutorial. So some example assignments. Here are all the whole number assignments. So it goes type, variable name equals, single equal sign, and then the value you want to hold, and then semicolon. And then here's the declarations for the non-whole numbers. Float always has to have an F to denote that it's a float. Similarly, long always needs an L to denote that it's a long. And then for double, you can include the decimal place since it can be a non-whole number. And then booleans, as mentioned before, are either true or false. And then characters can be declared and assigned with with the character in single quotes or by ASCII values. So a note on variable names. Different languages have different conventions for variable names, but in all the languages, a variable name has to start with a letter. It can contain letters and numbers. It can't contain spaces, and it should be descriptive and easy to understand. In Java, regular variable names are camel case. An example would be hello world. So this camel case means that at word breaks, the letter is capitalized, and they always start with lowercase letters. And in constants, which we discussed later, are all caps with snake case. So an example would be hello world with this underscore between word boundaries. So putting it all together, let's say that this set of zeros is memory. And somebody executes the code int x equals 0. Well, that sets aside these 32 bits for the integer, and this is the memory address. Dead beef is just a word that is valid, and it's a valid hexadecimal number. And then if somebody executes x equals 3, it updates what's in memory to match this 3. So this is 3 in binary. And there's a tutorial later on this playlist that explains exactly how binary and hexadecimal both work. But now this is what x is according to the computer. So we're going to do a cast demo now. I have this cast demo starter on my desktop, and it's attached to this tutorial. So it starts like this, and I'm going to open up IntelliJ, so that way I can actually do the cast demo and you can see it as it goes. So it's loading, and you should already have IntelliJ on your computer and set up with at least one project you can work in. So I have this Lunch and Learn set up, and I'm going to go ahead and open it. Okay, I don't need this tutorial. So I'm going to go source, and then new Java class. I'm going to name it cast demo. And then I'm going to copy this. Okay. I'm going to exit that. Okay. So now I have these declarations, and I'm going to go ahead and change this to 2.3 so it's more obvious how the casting works later. I'm going to change this to 3.1. Okay. So, cast examples. So we have byte B and short S, and we know that a byte is smaller than a short. So I can do short to byte, or byte to short equals B. And you can see that this didn't require any explicit casting because byte is smaller than s. So I'm going to say implicit cast since byte is smaller than short. But if I try to do byte short byte is equal to s, I get this error. And it says incompatible types, required byte but found short. And that's because a short is bigger than a byte and the computer can't automatically stuff it in. So what you have to do is be explicit and put byte there. So I'm saying have to be explicit since byte is smaller than short. And that is true of all casting back and forth. You can set a bigger type to be a smaller type without an explicit class because it sort of fits in without having to do anything. But you can't set a smaller variable to a bigger type without a cast because the computer has to know to shrink it down. And the way that it does that is it cuts off extra information. So for instance, if we do int double to int equals int d, and I'm going to say that explicit cast since int is smaller than double. And since int is smaller than double, there's extra information in double that had to be taken away when we went from a double to an integer. So we're going to print out .println double to int, just so we get an idea of what happened. So I'm going to say run, and it's going to ask me which one I want to run. I'm going to say cast demo, and it's going. So it printed out 2. And that's because what happens when you go from a floating point number to a whole number is the information gets truncated. So it just sliced off the decimal part. If you want it to round up or round down, there's some stuff you can do with the math class, which we're going to talk about in a later tutorial. And you can go from a character to an integer. So for instance, if I want to go int car to int equals C1. So what this will do is we'll print out the Unicode value of whatever A is. So I can do system.out.println char to int. And again, this doesn't need an explicit cast with the type in parentheses because character is smaller than integer. And I got 65 because the ASCII value for A is 65. Let's get this down farther. Okay. So if I know that byte is fewer than 16 bits, right? So if I want to do something like byte car to byte C1, I get an error here, right? And that's because the types are incompatible because their sizes are off. So here I can do byte cast because it has to be explicit. And again, I can print out char to byte, and hit play. And remember what the size range, what the range was for byte. Since the range can cover 65, it just prints out 65 like normal. If the value of character had been outside the range of byte, so larger than 2 to the 8th, larger than 2 to the 7th minus 1, then it wouldn't have worked. So just keep that in mind. The value would have had to print out differently because it would have had to chop off the extra part that was outside of the range. Okay, explicitly. And I don't think I mentioned this before. The way explicit casting works is you put open parentheses, the new type that you want the variable to be, closing parentheses, and then the variable that you're casting. This gets more complicated when we start using methods later, and we'll talk about that when we talk about methods. Much later in the tutorials, whenever we get to objects. But for now, it's pretty simple. Just the new type in parentheses, and then whatever you're trying to cast. So yeah. And in case you're curious, Boolean isn't something that can be converted nicely to any of these number values. So for instance, I can't do something like int Boolean to int equals truthy, because I get the incompatible types, which before we tried to fix by including this cast, and I still get that it's inconvertible types. You can't cast Boolean to int. So something to just be aware of, that sometimes casting doesn't work, and then the computer will warn you with a compile error. Okay, so that's the cast demo. And we're going to talk about the final keyword. Final is something you use if you know you won't be changing the value of a variable. So for instance, final int I equals 0. And this works for variables that you want to keep the same throughout the running of the program. And a last note on types. When you're deciding which type to use for a variable, try to pick one that makes the most sense. So for instance, you wouldn't use a double when you aren't going to use the decimal part of it. Examples: the number of days it rained last year would be an int. The average group of numbers would be a double. And then if the current month has a y in it, would be a Boolean. So now we're going to talk about expressions. So some vocab. An operator is something that combines multiple values or expressions. And the main ones we're going to focus on are plus, minus, divides, multiplies, and modulus. And we'll talk more about what this means on a later slide. And then expression. An expression is a combination of values and or operations that result in a new value. An example is 1 plus 4 times 5, 7 plus 2 quantity, times 6 divided by 3. So the percent or modulus operator. A modulus is a way to get the division remainder between two numbers. Some examples are 14 mod 3 is 2, since 3 times 4 plus 2 is 14. 8 mod 2 is 0. Modding something that goes into the first number evenly will always give you 0. So modding by 2 is a really quick way to know if a number is even or odd. Even numbers will always give you 0 when modded by 2, and odd numbers will always give you 1. 230,857 mod 10 is 7. So modding by 10 is a way to give you the last digit of any number. You can also get the last 2 by modding by 100, and so on. 3 mod 7 is 3. So modding a small number by a larger one will always give you the smaller number again, right? Because 0 times 7 plus 3 is 3. And then 2.4 mod 3.0 gives you 0.40036. So the extra digits come from the fact that doubles aren't represented in an exact way in the computer, so sometimes you get weird output because of this imprecision. And in a later tutorial, we'll talk about how to use formatting to get rid of these extra decimal places. But just something to keep in mind as you're doing math with doubles. And then there's integer division. When two ints are divided, the result is another integer that is the exact number of times one number goes into the other. So 21 divided by 5 is 4. 84 divided by 10 is 8. 30 divided by 6 is 5. And 8 divided by 9 is 0. So if you want to get an exact division with integers, you'll need to cast one of them to a double first. An example would be double 21 divided by 5 is 4.2. So that's integer division. And then operator precedence for in Java is PIMDAS. So the same as what you learned in algebra, except we have this extra M for modulus. So it changes to, please excuse my marvelously deranged Aunt Sally. And multiplication, modulus, and division all have the same precedence, so you apply it from left to right. And then addition and subtraction have the same precedence, and so they get applied left to right, just like before. So we're going to do some printing of variables and expressions. So let me comment this out, actually, so this compiles. Doesn't work because can't cast boolean to a number. Okay. So I say new Java class, and I'm going to name it variable and expression demo. And again, like all runnable Java classes, this has to have a public static void main string args. Okay, so you can print expressions, and what will happen is it will print whatever the result of that expression is. So I can do something like system.out.println 2 plus 4 divided by 3 times 6. And if I do run, I want to do the variable and expressions demo. So the answer to that is 8, right? And we get 8 because it did the multiplication and division first, since it has precedence. So 4 divided by 3 is 1, because it's doing integer division. And then times 6 is 6, plus 2 is 8. So that works as long as you're doing just expressions. It will always just keep printing the result. I can also save off expressions in variables by doing something like int result equals, and I'm just going to copy this same expression. So I'm going to say, I know that result equals 8. And then I can do system.out.println result. So now I should have 2 8s in a row, which I do. And I can also put some wording with my variable, right? So I could do system.out.println results plus results. So now when I run it, I have the word result and then a space and then the value. There is something, there's sort of a wrinkle. Once you append a variable or a number to a word, it gets converted into a word, and any expression done after that won't actually do what you would expect it to. So if I do something like system.out.println results plus 2 plus 4, you would expect it to be result 14, right? Because 8 plus 2 plus 4 would be 14. But if I press play, what I actually get is 824. And that's because once this happened, it became a word, and so everything that happened afterwards was seen as just adding more letters to the word. So it added 2 and 4 like they were letters. And if you don't want that to happen, what you can do is put the expression that you want to be evaluated inside of parentheses. So now it should actually be result 14 like we want. And if you want to do more words after the expression or variables, you have to do another plus and then more words in quotes. So actually did math. So now when it prints, it looks like that. You have to keep in mind whenever you are using words and expressions together with these pluses, you have to put in the space with the quotes that you want, or else everything will end up being squished together. Because the spaces between these quotes and the plus signs don't count towards the words that actually get printed. Right, so that's variables and expressions. This is kind of going over what I just talked about. When you're printing variables and expressions, the words always have to include a plus between the variable or expression and the words in quotes. You'll get compile errors otherwise. So if I went back here and removed this plus, I would get this swag squiggly because it's expecting something. And it won't tell you that it's expecting a plus. It tells you that it's expecting the expression to end. So you just have to know that pluses go between these expressions and the words and quotes. And once you're done, you have some words plus the variable expression. It becomes a non-number type, and any operations will no longer work as they normally would. And so just an example like we did before, hello world plus 3 plus 4 would give you hello world 3, 4 instead of hello world 7. So for a practice problem, what we're gonna do is write a program to calculate a total at a restaurant based on the subtotal. We're gonna have to calculate both tax and tip and add them to the subtotal to get your final total. So we're gonna say that tax is 8% and that the tip should be 15% of the subtotal after tax has been added. So we're going to do the practice problem. And you can follow along or try to do this by yourself before you see the solution if you want to. But I'm going to create a Java class called receipt. And again, I have to do public static void main string args. So I'm going to start with int subtotal equals 45. So does it make sense for subtotal to be an integer? It actually doesn't, right? Because subtotals at restaurants are very rarely whole numbers, and I want to make sure that all the math I do after this is double math. So I'm going to change this to be double 45.32. And then I'm going to say double tax percent is 0.08, right? So that's actually 8%. And then I'm going to say double tip percent equals 0.15 because it's 15%. So now what I want to do is calculate what the subtotal plus the tax would be. So I'm going to say double total with tax equals subtotal plus subtotal times tax percent. So now I have the total with tax, and I want to get the total with the tip. So I'm going to say double total with tip. And since I want to tip on the subtotal plus tax, I'm going to do total with tax plus total with tax times tip percent, right? So now I'm going to print out some information for what you would kind of normally see on a receipt. So I'm going to say system.out.println where subtotal is plus subtotal. System.out.println your total with tax is plus total with tax. And then system.out.println final total plus total with tip. Okay, so now I can do run and then run. And I want to run receipt. So it's loading. And now I have this. So my subtotal was 45.32. My total with tax was 48.9456, which we would probably want to round to the nearest penny. And then the final total was 56.28744, which again you would want to round to the nearest penny. And we don't know how to do that yet, but it's something I'll show you how to do in a later tutorial in terms of printing out this so that it makes sense as a 4-digit number as opposed to a 7-digit one. And again, these extra digits are coming from the fact that doubles aren't stored precisely in the computer, right? They have a little bit of inconsistency with them. And then a practice problem for later was to write a program to these specs. So you have a variable for your age, a variable for how many decades old you are, calculated from your age variable using integer division, a variable for how many years you are into your current decade, calculated from your age variable using modulus, has a variable for how close you are to 100 as a percentage calculated from your age variable using non-integer division, and has a variable for if you're over 30. And then you should print out all these values with appropriate words surrounding them to give them context. Some example output. So this is pretending that I'm Grace Hopper, who was an admiral in the Navy who was working on a lot of computer science concepts in the early years of computer science. So it would be, hi, my name is Grace Hopper. I was 85 years old when I died in 1992. That's 8 decades. I was only 5 years into my latest decade. I was 0.85 of the way to 100 years old. And was I over 30? True. And this is a little bit awkward, just printing out the word true, but it's what we have for now, since we don't know how to use conditionals based on whether or not a Boolean is true or false to do one action or the other. And Grace Hopper was a great woman in tech, and you can learn more about her on her Wikipedia page. There's actually a giant tech conference every year named after her called Grace Hopper. That's a tech conference for women. And that's it. I hope that was helpful. If there's going to continue to be tutorials from this point forward building up on Java, and we'll learn Java along the way. The final goal is to write Pong in Java. So that'll be cool.